Now I'll solve a system of linear equations by uh, elimination. So this is elimination. So elimination, the goal is to get the coefficients of the like variable terms from each equation to be opposites of each other. So you choose a pair of the same variable in two different equations, and then you try to get their coefficients to have the same number but opposite sign. So it's obviously easier when you choose one of the variables that has a coefficient of 1, because it's easy to get 1 to be any other number. For instance, I could use this x, which with a coefficient of 1, and I can easily change 1 into -2 or +3. Or also I could use this z, which has a coefficient of 1, because it would be easy to turn this with multiplication into a 10, -10, or a -4. I'm going to choose the former. I'm going to take x, and I'm going to eliminate the x's in the bottom two equations. To keep the equation straight, I'm going to call the top equation A, and no matter what happens to the top equation, I'll continue to call it A. So A really represents the first row. I'll call the second row, or the second equation, B, and I'll call the third row, third equation, C. So here's the first thing I'm going to do. First thing I'm going to do is I'm going to take A, this entire equation, multiply it by -2, and then add it to equation B. That way the -2x and the +2x will cancel out. When I get a solution for that, I'm going to replace equation B, this entire second row, with that new equation. So here we go. So first, equation A is going to stay the same. X minus 3y plus 4z is equal to 7. Now I'm going to take, what I'm doing is I'm going to take -2, multiply it by equation A, and add the result to equation B. And that's what I'm going to use for my new second row. So let's see, -2 times x is -2x. When I add that to +2x, they cancel out. -2 times -3y is +6y. When I add +6y to -5y, I just get a +1y. And then -2 times 4z is -8z. And if I take -8z and add it to +10z, I'm going to get +2z. And I'm not done, I still have the other side. When I multiply -2 by 7, I get -14. And then -14 plus 21 is equal to +7. So I get this second equation, row B, turns into this, and my third equation is going to stay the same. So the only equation that changed by doing this was the second equation, the one that I was adding -2a2. 11y plus, oops, let's see, let's keep these lined up. So I'll have -3x, a plus 11y, and a plus z still equal to 20. So now this is still A, this is still B, and this is still C. Remember, I'm just using A, B, and C to denote which row I'm looking at. All right, now what I want to do is I want to also get rid of the x down here. So if I want to get rid of that x, I need to make this x's coefficient, I need to change it from 1 into +3. So I'm going to take the first equation, equation A, multiply by +3 so I can get +3x, and I'm going to add that to equation C. I'm going to add that to equation C. All right, so equation A and B are going to stay the same. X minus 3y plus 4z equals 7, and y plus 2z is equal to 7. But now equation C, when I multiply equation A by 3, I'll get 3x, and when I add 3x to -3x, they cancel. I'll get 3 times -3y is -9y, and -9y plus 11y is 2y. And When I multiply 3 times 4z, I get 12z, and 12z plus 1z is 13z, positive. And then when I multiply 3 by 7, I get 21, and 21 plus 20 is 41. So there I have A, B, and C still. But if you notice, B and C, those are two equations with only two unknowns. All right, so I'm going to start focusing on B and C and see if I can't eliminate one of those variables. All right, so what I'm going to do is I'm going to go ahead and I'm going to try to eliminate y now, because notice y has a coefficient of 1 here. So it's easy to get this positive 1 to be a negative 2 so that when I add it, it'll cancel this one out. So now I'm going to take equation B, I'm going to multiply it by negative 2, and I'm going to add it to equation C. That way, the y will be gone, and I'll only have an equation with z left in it. So let's see. Equation A will stay the same. X minus 3y plus 4z is equal to 7. Equation 2 will stay the same. Equation B will stay the same. Y plus 2z equals 7. But now equation C is going to be what I get when I multiply negative 2 times equation B and add it to C. So negative 2 times y is negative 2y, plus 2y is 0. Those go away. Negative 2 times 2z is negative 4z, and negative 4z plus 13z gives me a 9z. And then negative 2 times 4, or negative 2 times 7 is negative 14, and negative 14 plus 41 is equal to 27. So 27. And this is now my equation C. I don't know if you noticed, but equation C is now one equation with one unknown. If I want, I can just solve that equation for Z. So solving equation C for Z, I get Z is equal to 27 over 9, or Z is equal to 3. Once I know that Z is equal to 3, equation B has only Y and Z in it. So I can plug my value for Z into equation B to get the value of Y. So I now know that Z is equal to 3. Let's find the other two values. I also know that Y plus 2 times Z, which is 3, is equal to 7. So this says that Y plus 6 is equal to 7. So that means that Y is equal to 1. And then on the very top, I have an equation that gives me a relationship between x, y, and z. So if I know y and z, I can find x. And I do know y and z, I just found those. So let's go ahead and find x. It turns out that uh, x minus 3 times y, which is 1, plus 4 times z, which is 3, is equal to 7. So I get x minus 3 plus 12 equals 7. 12 minus 3 is a 9. And we get that x is equal to negative 2. So once again, here we have it. Negative 2 comma 1 comma 3 is the solution to this system of equations, and that method was the method called elimination.